Welcome to your last lesson on the speed and forces topic. Today's lesson title is Distance Time Graphs. In a distance time graph, distance is plotted on the y-axis, which is the one going up, and time is plotted on the x-axis, which is the one that goes across the page. With a distance time graph, a horizontal line like this shows that an object is stationary because the object is at the same distance over a period of time. A straight diagonal shows an object is moving at constant or steady speed. So we have examples here, here, and this red line here, which is a different object. A curved line not shown on this graph tells us that the object is either speeding up or slowing down. So, a distance time graph plots the distance an object travels against the time it takes to travel. We're going to follow the car's journey with a distance time graph. So the car was moving at constant speed and now is stationary. It is moving again at constant speed, but at different speeds. So, the steeper the line, the further the car moved in a shorter amount of time. So it must have been going quicker. So at this point, between 6 and 8 seconds, the car was going quickest. And it was going slower here and here. And it was stationary between 4 and 6 seconds. So, I'm going to show you how we sort of look at these questions. So the first question is, how far did the car travel in the first 3 seconds? So we're going to read up from 3 seconds and across to 60 metres. So the answer is 60 metres. Because we know that the car had travelled 0 metres at 0 seconds. How long was the car stationary? So we find the section where the car is stationary, draw 2 straight lines down, and we can see we were stationary between 4 and 6 seconds. So we were stationary for 2 seconds. What was the car's greatest speed? So the greatest speed is going to be the steepest section of our graph, so we're going to be looking here. And to calculate speed from a distance time graph, we calculate what we call the gradient. So that's the steepness. And we do the height of the triangle drawn, which is 100 metres, because it's between 80 and 180. And we look at the width, which is 2 seconds between 6 and 8. And then we do speed, is the height divided by the width, so 100 metres divided by 2 seconds, and that gets us 50 metres per second. Last question, what was the car's average speed for the whole journey? So we need the total time, which is 10 seconds, and the total distance, which is 220 metres. So we do 220 metres divided by 10 seconds to get 22 metres per second. Here is a different graph. This graph shows a cyclist's journey from home to the next big city and back. So, how long in total was the cyclist stationary during his journey? So we've got a bit here that goes from 1.5 hours to 2, so that's half an hour. And then we've got a section here that goes between 3 and 4, so that's another hour. So 1 hour plus half an hour is 1 hour and 30 minutes. Then it says, how far did the cyclist travel in total? So the cyclist travelled this far, which is 35 miles, but they went there and they came back again. So we have to multiply 35 by 2 and get 70 miles. What was the cyclist's speed on the way home? So we need to do the height divided by the width. So we would draw our triangle. The height is 35 miles. The width is 2.5 hours, 4 and 6.5. We divide 35 by 2.5, which is what we were practicing last lesson, calculating speed. And we get 14 miles per hour. It then says, what was the cyclist's greatest speed? So we need to look at which part of the graph is steepest, and it's this. And we do the same again. We do the height, which is 20 miles, divided by the width, which is an hour, to get 20 miles per hour. Have a go at this one on your own. So a train travels from Goldenrod City to Saffron City. The train leaves at 9:15 and stops at Route 32 here along the way. The distance time graph shows the train's journey. So pause the video and have a go at these 5 little questions. Part A. What is the distance between Goldenrod and Route 32? So we have to take from here to here. So we measure across, and it's 110 miles minus 0, 110. How long did the train stay at Route 32? So it stayed from 10:30 until 11. So that's 30 minutes. What speed did the train travel from Route 32 to Saffron City? Well, it was there for 45 minutes, and it travelled 90 miles. So we do 90 miles divided by 45 minutes and we get 120 miles per hour. You may have also worked that out per minute. So miles per minute, which isn't as common but would still be okay, and that would be 2 miles per minute. How far did the train travel in total? Well, it went the first 110 and then another 90, so that's 200 miles. The train's average speed for the entire journey, well, it travelled 200 miles and it took 15, 30, 45 an hour. So that would be 2 hours, 2.5 hours. So we do 200 divided by 2.5 and we get 80 miles per hour. Have another go with this question. Callum cycles from his home to the supermarket and back. The following distance time graph describes his journey. Pause the video here and answer these questions. Part A. How long did it take Callum to get to the supermarket? So, he left at 11:40 because each 2 squares is 10 minutes. And he arrived at the supermarket at 12:10. So that's going to be half an hour or 30 minutes. How long did Callum spend at the supermarket? So from 12:10 until 1:55. So he spent 45 minutes. What was Callum's speed on his journey home? So, how far did he travel? He travelled 4.5 miles. So that's our distance. And then our time is from 5:1 until 5:10. 20 past 1. So it took him 25 minutes. So you do 4.5 divide by 25 minutes times by 60 to get to hours, and we'll have 10.8 miles per hour. What was the total distance Callum travelled? Well, he travelled 4.5 miles there and 4.5 miles back, so it's 9 miles. How long was Callum away from his home for? So he left at 11:40 and got back at 1:20. So he was away for an hour and 40 minutes. Final question. Paul travels to his parents' house and then returns home. The distance time graph shows information about Paul's journey. So it says, what time did Paul start his journey? Pause the video and answer these questions. Paul started his journey at, so there's 1, 2, 3, 4, 5, 6 gaps in an hour, so each gap is 10 minutes. So it was 10 minutes past 12:30, so he started at 12:40. Paul stops at a shop on the way. How long does he stop for? Well, he stops for 1 gap, and we've just said each gap is worth 10 minutes. How far do Paul's parents live from the shop? So, they live 7 miles, because it's halfway between 6 and 8, from his house. But the shop is 4 miles from his house. So we do 7 minus 4, and we get 3 miles. Work out the total distance travelled by Paul. Well, he had to travel 7 miles there, and he travelled 7 miles home. Oh, sorry, so it's 14 miles. And we can calculate that his average speed on the journey home was 21 miles per hour because he travelled 7 miles in 20 minutes. So if you do 7 divided by 20, that gets you 7 divided by 20 gets you how many miles per minute. We times that by 60 and that gets you 21 miles per hour. So if you're stuck with converting between miles per minute and miles per hour, please do talk to your teacher about it. And I will see you all soon. Have a good rest of your day.